Good day, everyone. You are welcome to class. If today is your first time of joining this platform, you are wholeheartedly welcome to this great family of scholars. And to my returning subscribers and followers, thank you for always coming back. On this platform, I teach mathematics and physics. But for today, I'll be teaching a topic in physics. Without much ado, let's jump right into what we have for today. But before we start, I want to leave you with these statements as I've always done. What you don't know is more than you. As a result, stay put and watch this video from the beginning to the end so that you can know what you never knew before as far as physics is concerned. So today, we'll be looking at the part 2 in the scalars and vectors series, which happens to be the addition of vectors. In the part 1 of scalars and vectors series, we talk about the concept of vectors, we talk about the concept of scalars, and we also talk about how vectors are represented. So before you watch this video, it is better you go and watch the previous video, which is the part 1 of scalars and vectors, so that you can follow through while watching this video. So today we're looking at addition of vectors. From the word addition, in mathematics, addition means to come together. Addition means sum. So when one or two things come together, it gives us a particular thing. So that coming together of two things is called what? Addition. That addition of that two things will give us what? One thing. So we say the sum of two or more vectors acting on a body in a given direction results in a single vector, which will have the same effects in magnitude and direction as the two or more vectors acting together. That single vector is called the resultant vector. Now let me put it this way. If this is vector A being added to a vector B, these two vectors will add up to give a vector C. As you can see, this one, there are two vectors that added up to give what? One singular vector, which is what? Vector C. This vector C will have the same effects in magnitude and direction as these two words vectors acting together. So the vector A and the vector B, which are the individual vectors that were added together to give this word singular vector called the resultant vector, are called the components of the resultant vector. So A and B is seen as a component of the resultant vector C. The question is, what then is a resultant vector if you are asked to define it in an examination condition? Resultant vector is that singular vector which would have the same effect in magnitude and direction as the original vectors acting together. The question now is, how do we get the resultant word vector from the addition of two or more vectors? If you remember, in the part 1 of scalars and vectors series, I told you that vectors are added by geometric method. So that means it depends on what? Angles and lines. That means it depends on what? The direction of what? The various vectors. So the question is, how do we get the resultant vector of vectors? The conditions and procedures for obtaining a resultant vector depends on the possible direction in which the vectors act on a body. So the first condition we'll be looking at is when the two vectors are acting in the same direction. How do we get the resultant vector when the two vectors are acting in the same direction? That's the resultant of two vectors acting in the same direction. How do we get it? Now let's take this example under this resultant of two vectors acting in the same direction. So let's take this example. If two force vectors, remember that force is an example of what? A vector. In the part 1 of the scalars and vector series, I gave you a list of examples of vectors in which force is one of the examples of what? Vectors. So if two force vectors of magnitude F1 equals to 3 Newton and F2 equals to 4 Newton act on a body as shown in the figure below. This is the body. So solution. So let's see how we get the resultant of these two bodies that are acting in the same direction. As you can see, they are acting in this direction. This arrow, they are moving in the same direction. So how do we get the resultant? That singular vector that we have the same effects in magnitude and direction as these two forces acting on a body. So look up. So to get the resultant, let's see the resultant as arrow. Arrow will be equal to, so to get the resultant of two vectors acting in the same direction, you add the two vectors together. So if you add these two vectors together, the answer you get becomes the magnitude of the resultant vector. So look up. This becomes what? F1 plus F2. So your arrow will be equal to, what's your F1? Your F1 is 3 Newton. So put 3 here. Plus, what's your F2? Your F2 is what? 4 Newton. And this will give you what? 3 plus 4 will give you what? 7 Newton. This becomes the magnitude of the resultant force vector. But remember that the resultant vector is the singular vector which would have the same effect in magnitude and direction as the what? Original what? Vectors acting what? Together. So right now we have gotten only the magnitude of the resultant vector. We also need to find the direction of the resultant vector. I must say again, when the two vectors are acting together, are acting in the same direction, to get the resultant, you add them up. That's why you see plus here. So now adding them up gives you the magnitude of the resultant vector. Now how do we get the direction of the resultant vector? Since the two vectors are acting in the same direction, automatically the resultant vector will also be acting in the same direction. So the two vectors are acting in this direction, which is what? Eastward direction. So therefore, the resultant vector will also be acting in what? In the eastern direction. So this will be what? 7 Newton. So we have gotten the resultant vector of these two vectors as 7 Newton in magnitude, and in this what? Direction. That's the eastern direction. So we are able to get what? The resultant vector of F1 and F2 acting on this body. Now let's look at the second condition for finding the resultant of two vectors. So second condition of finding the resultant of two vectors is when the vectors are moving in opposite direction. So the resultant of two vectors acting in opposite direction. So to find the resultant of two vectors acting in opposite direction, what do we do? Solution. As you can see, this vector f1 is going to the right. So it's going to the left. While this vector f2 is going to the left. So they are moving in opposite direction. So to get their resultant, it will be the bigger vector. So it will be the smaller vector minus the big, it will be the bigger vector minus the smaller vector. So that means to get the resultant arrow of two vectors acting in opposite direction, it will be what? The bigger vector, which is f2, minus the smaller vector f1, and that will be equal to f2 is what? 4 minus f1 is what? 3. So 4 minus 3 give us what? 1 Newton. So this 1 Newton is the magnitude of the resultant force vector. Now, how do we get the direction of the resultant force vector? To get the direction would be the direction in which the bigger vector is acting. And if you observe very well, the bigger vector is acting to the what? The eastern direction. It's acting to your right. So therefore, the direction of the resultant vector will be like this, acting to the right. So we are able to find the resultant vector of two vectors acting in opposite what? Direction. And in finding the resultant vector, we find both the magnitude and the direction, because the resultant vector must be that singular vector which should have the same effect in magnitude and in direction as the original what? Vectors acting together. Now let's find the resultant of two vectors acting perpendicularly to each other. As resultant of two perpendicular vectors acting at a point. The first question you should ask yourself is, what are perpendicular lines? Perpendicular lines are lines that forms angle 90 with each other. An example is this. So that means when a vertical line meets an horizontal line, it forms an angle here. And this angle it forms is called angle 90. So because of this angle 90 formed, it means that this line and this line are perpendicular to each other. Now the question is, how do we find the resultant of two vectors that are perpendicular to each other? Now in finding the resultant of two vectors that are perpendicular to each other, we use Pythagoras theorem and trigonometric ratio. The question is, how do we go about it? So look up. So let's take this question. It says, find the resultant of the forces acting on a body as shown below. These are the two forces acting on this body O. So how do we find the resultant? Solution. The first thing you will do is to form a parallelogram from these two vectors. The question is, what is a parallelogram? A parallelogram is a flat shape with four straight sides in which the opposite sides are equal and parallel. So let's form a parallelogram from these two vectors like this. So we have formed a parallelogram using these two vectors. Now as you can see, this is a parallelogram. This parallelogram can either be a square or a rectangle. But for this particular one, it will be a rectangle. The reason I can't say here. If you want me to tell you the reason, write it in the comment section. Then we'll do a video on how to know whether this parallelogram is a rectangle or a square. Now, we have formed the parallelogram. Remember I said parallelogram is what? It's a flat shape with what? 4 straight lines. Look at the 4 straight lines. Line OB, line BA, line AC, and line CO. These are the 4 straight lines in which the opposite sides are parallel and equal. That means the side OC and the side BA, they are equal. And also what? Parallel. What are parallel lines? Parallel lines are lines that can never meet. So look at these two lines now. If you're going to extend this line, I'm going to extend this line too. Will they ever meet? I guess your answer is what? No, they can never meet. But look at this line. If you have a line like this, another one like this, if you're going to extend it, I guess you agree with me that it will meet this line. This line will meet this line. So these two lines cannot be called parallel lines because they are lines that because they are what? These two lines will always what? Meet. So parallel lines are lines that can never meet. So therefore, side OC and side BA, they are parallel sides, and these two parallel sides are also equal. Also, OB and CA are also parallel and also what? Equal. So that means since OC is F2 equal to 4 Newton, BA will also be F2 equals to 4 Newton. Also, since OB is equal to CA, therefore CA will also be what? F1 equals to 3 Newton. So I haven't drawn this parallelogram. So the question now is, how do we get the resultant vector of these two vectors? I haven't drawn the parallelogram. In getting the resultant vector, you must know a particular law called what? The parallelogram law of vectors. Now the parallelogram law of vectors states that if two vectors are represented in magnitude and direction by the adjacent sides of the parallelogram, the diagonal drawn from their point of intersection, which is this place, the diagonal drawn from their point of intersection represents the resultant vector of the two vectors in magnitude and direction. So this becomes the resultant vector of these two first vectors, F1 and F2. Where the arrow here, which is this length, represents the magnitude of the resultant vector, while the angle that this diagonal makes with the horizontal gives you the direction of the resultant vector. The question now is, how do we get this arrow which stands for the magnitude of the resultant vector? And how do we get this alpha which stands for what? The direction of the resultant vector. For us to get arrow, we must bring out this right angle triangle OCA from this parallelogram. So let's draw this right angle triangle. Like this, we have like this, then we have like this, then we have like this. Where this is your O, this is your C. This is the direction of this line. This is the direction of this. This is your arrow. This is the direction of this. This is your F1, which is equal to 3 Newton. While this is your F2, which is equal to 4 Newton. While this is the angle that the resultant vector makes with the horizontal. That angle will be given as alpha. So where your arrow is the magnitude of the resultant force vector, as I've said earlier, then use your alpha is the direction of the resultant force vector. So one thing you should know about this particular kind of parallelogram, which I say it can either be a square or a rectangle, is that the 4 angles are angle 90. That means this angle here is angle 90. This angle here is angle 90. This angle here is angle 90. So therefore, if this angle here is angle 90, that means this angle here, let me clean up this. That means this angle here is angle 90. So we have this triangle OCA. This triangle OCA is called a right-angled triangle. We have different types of triangle, but this particular one is called a right-angled triangle. Now, why is this one called a right-angled triangle? It's called a right-angled triangle because one of its angle is angle 90, and as you can see, there's an angle 90 here. So because of this angle 90, that's why this triangle is called a right-angled triangle. And remember, a triangle is what? A 3-sided shape. So look at this triangle now. OC, CA, AO. How many sides? 1, 2, 3. 3 sides. So a triangle is always has what? 3 sides. So when a triangle has a right angle as one of its angles, we call that triangle a right-angled triangle. So in getting this, your arrow, which is the magnitude of the resultant vector, we apply Pythagoras theorem. Now, what did Pythagoras say? Pythagoras says that for a right-angled triangle, that means Pythagoras rule can only be used in what? A right-angled triangle, not in any other type of what? Triangle. So Pythagoras theorem says that in a right-angled triangle like this, the hypotenuse square, I'll write the short form, hypotenuse square is equal to the opposite squared plus the adjacent squared. The question that may be bothering your mind is, how do we know hypotenuse? How do we know opposite? And how do we know adjacent in a right-angled triangle? Now I'll tell you. The first one, you start from the hypotenuse. The hypotenuse, there are 2 ways to know the hypotenuse. The hypotenuse is always seen as the longest side of a triangle. But the best way to know hypotenuse, as far as a right-angled triangle is concerned, is that the hypotenuse is the side that is facing the angle 90. So having gotten that, that means your hypotenuse is your what? The side OA. So we have OA squared equals to, the opposite is the side that the angle we are looking for is facing. Remember, we are going to look for this angle. So the side that this angle is facing is the opposite. So your opposite is your what? CA. CA squared plus, automatically the last side becomes the adjacent. So the adjacent is now what? OC. So now I have OC squared. So where your OA is what? Your arrow. So now I have arrow squared equals to your CA. Your CA is your what? Your F1. F1 squared plus your OC. OC is your F2. So now I have F2 squared. So therefore your arrow squared is equals to F1 is what? 3 Newton. So we have 3 squared plus F2 is what? 4. So we have 4 squared. So your arrow squared will now be equal to 3 squared means 3 times 3, that's 9. Plus 4 squared means 4 times 4, that's 16. So your arrow squared will now be equal to 9 plus 16 will give you 25. Therefore, for us to find arrow, we have to take the square roots of both sides, because what we are looking for is arrow and not arrow squared. So taking the square root of both sides, we have square root arrow squared equals to square root 25. Square root, we cancel square. What will be left here is arrow equals to the square root of 25 is 5. So now I have 5 Newton. This 5 Newton is the magnitude of the resultant vector of these two vectors, F1 and F2. Now the question now is, how can we find the direction of the resultant vector of these two vectors, F2 and F1? And that direction is represented by this alpha. And that's the angle that the resultant vector makes with the horizontal. So the direction of the resultant vector of these two vectors, F2 and F1, will be your what? Alpha. So how can we get alpha? That is the question. Now, in getting alpha, we have to use trigonometrical ratio. In your mathematics, you have something like this. So, toi, where the S here stands for sine, O here stands for opposite, H here stands for hypotenuse, C here stands for cosine, A stands for adjacent, H stands for hypotenuse, T here stands for tangent, O stands for opposite, and A stands for adjacent. And in all these three, the one we are to use for us to get the direction of the resultant vector will be what? Toi, where your T stands for tan. Tan what? The angle. Tan the angle, the direction of the resultant vector, that's alpha, equals to your O is what? Opposite, all over the adjacent. So your tan alpha will now be equal to what? What's your opposite here? Your opposite, we've gotten the opposite to be 3. So we have 3 over, and the adjacent to be 4. So your tan alpha is equals to 0.75. So what are we looking for? We are looking for alpha and not tan alpha. So what are we going to do to make alpha the subject of formula in this equation? We have to divide both sides by tan. And by so doing, we have that tan divided by tan all over 0.75 divided by tan. Tan, we cancel tan. What will now be left here is what? Alpha. Alpha will now be equal to... Now, in this case, there's an imaginary one here. That 1 divided by tan is seen as tan inverse. Then you now put this your value here, this number here in the bracket, 0.75. Alpha will now be equal to 36.9 degrees approximately. So 36.9 degrees becomes the direction of the resultant vector of these two vectors, f1 and f2. Now before we go, take down this assignment. A boy walks a distance of 2 kilometers eastwards to a point A and then walks another distance westwards. What is his displacement from his starting point? Then the second question says, a man starts from point A and walks 3 kilometers eastwards and then 4 kilometers southwards. What is his displacement from the starting point? Solve this question and drop your answer in the comment section. With this, we have come to the end of today's class. If this video has been helpful, please give it a thumbs up. Click on the notification bell if you have not done that already, so that whenever I post, you'll be the first to see my post. Also comment, write what you think about this video, write it on the comment section. Also share to as many people as possible. And above all, subscribe if you have not subscribed already. And as you do so, may God bless you richly. One love.